Hi, I'm Sayed on Mass Online. Today I'll be dealing with the topic on angle between pairs of curves. In one of my video, I've already shown you the formula for angle between the pairs of curves. You can watch that video on the angle between the pairs of curves. So let me write down the formula over here. Angle between the pairs of curves is given as modulus of phi1 minus of phi2. So let us take few examples based on this formula. So the first question is find the angle between the pairs of curves r is equals to sine theta plus cos theta and r is equals to 2 sine theta. So let me consider the first curve. R is equals to sine theta plus cos of theta. So let me take log on both the sides. So if we take log on both the sides, we'll be getting log of r is equals to, it is log of sine theta plus cos of theta. So let us try to differentiate this with respect to theta. So differentiate with respect to theta. So differentiation of log of r will be 1 by r dr by d theta is equals to, on the right hand side, log differentiation will be 1 by, you have sine of theta plus cos of theta into the inner differentiation of sine theta will be cos of theta, and differentiation of cos theta will be minus sine of theta. We know 1 by r dr by d theta, its value is nothing but cot of phi is equals to, so here we have cos of theta minus sine of theta whole divided by sine of theta plus cos of theta. So I want to express the right hand side in terms of cot, since the left hand side is in terms of cot. So for that, I'll just try to divide by cos theta in the numerator as well as in the denominator. So in the numerator, so in short I'll write NVM, and in the denominator, so I'll write in short DEN. So we'll try to divide cos theta both in the numerator as well as the denominator. So if you divide in the numerator, you have cos theta divided by cos theta will be 1, minus you have sine theta divided by cos theta in the second term will give you tan of theta. It's whole divided by, so denominator you have the sine theta is being divided by cos theta, therefore we'll get it as tan of theta, plus cos theta is divided by cos theta, you get the value to be equals to 1. So its value will be nothing but 1 minus tan of theta divided by, so denominator I'll try to express that in the form of 1 plus tan of theta. So its value is nothing but cot of pi by 4 plus you have the angle as theta. So the formula for 1 minus tan theta divided by 1 plus tan theta is nothing but cot of pi by 4 plus theta. A similar result I have shown in my previous video. You can watch the video to know how we have got this 1 minus tan divided by 1 plus tan as cot. Cot of pi by 4 plus theta is nothing but 1 minus tan theta divided by 1 plus tan theta. So since you have on both the side cot value, so therefore the value of phi will be nothing but pi by 4 plus theta. Now since this is the first curve, I'll be taking the value to be equal. Since I have found out cot of phi for the first curve, I need to find out cot of phi for the second curve. So just to differentiate between the angles, for the first curve I'll be taking cot of phi 1. So I'll be taking cot of phi 1. Therefore we'll be getting phi 1 value to be equals to pi by 4 plus theta. So for the second curve I'll be taking cot of phi 2. So let me continue here. The second curve that we have is r is equals to 2 sine theta. Here also I'll be taking log on both the sides. So if we take log on both the sides, we'll be getting log of r is equals to, it is log of 2 sine of theta. This will be nothing but, if I use the properties of logarithm, it will be log of 2 plus log of sine of theta. Just using the property log m into n will be log m plus log n. Let us try to differentiate this with respect to theta. Differentiate with respect to theta. So derivative of log of r will be 1 by r into dr by d theta is equals to log 2 is a constant, so derivative will be 0 plus log differentiation will be 1 by sine of theta into differentiation of sine of theta will be cos of theta. So this left hand side value 1 by r dr by d theta is nothing but cot of 5. So since this is the second curve I am taking, I will be taking this as cot of phi 2. For the first curve I have taken cot of phi 1. For the second curve I will be taking cot of phi 2. So this will be equals to, on the right hand side you have cos by sine, which will be cot of theta. So since you have cot on both the sides, so the equality will be phi 2 is equals to theta. So we got phi 1 value as well as phi 2 value. Now let us try to write down the angle between the two curves. So therefore we have angle between two curves will be equals to this modulus of phi 1 minus of phi 2. So we know the value of phi 1 to be pi by 4 plus theta, minus we have phi 2 value. So phi 2 value, you can see I've got its value to be equals to theta over here. So let me just plug in over here. Its value will be theta. So if you try to observe over here, you have positive value of theta and negative value of theta will cancel out. Plus theta and minus theta will cancel out, and we are left out only with pi by 4. So since it is just positive value, we just write it as pi by 4 itself. So therefore you have got the angle between the two curves is pi by 4, which is nothing but 45 degree. So that's the required solution you have. So let us move on to the next question. Find the angle between the pairs of curves r square sine 2 theta is equals to 4 and r square is equals to 16 sine of 2 theta. So let me consider the first curve and try to find out the value of phi 1. Let us take the first curve, r square sine of 2 theta is equals to 4. So let us take log on both the sides. We'll be getting log of r square sine of 2 theta is equals to, it is log of 4. So using the properties of logarithm, we'll be getting log of r square plus log of sine of 2 theta is equals to, it is log of 4. Further using the property log m power of n will be n log of m. So 2 will come down, it becomes 2 log of r plus, it is log of sine 2 theta is equals to, you have log of 4. Now let us try to differentiate this with respect to theta. So differentiate with respect to theta. So we'll be getting 2 times of log r differentiation will be 1 by r dr by d theta plus second term log differentiation will be 1 by sine of 2 theta into differentiation of sine 2 theta will be 2 cos 2 theta is equals to, on the right hand side log 4 is a constant, its derivative will be 0. So further it is 2 times of, we have 1 by r dr by d theta is nothing but cot of phi. So since I am taking the first curve, I will be taking it as cot of phi 1, and over here we have plus 2, the constant as it is, you have cos by sine, which will be cot. So cot of 2 theta is equals to 0. So let us take this plus cot 2 theta on the right hand side. We get the value to be equals to 2 cot of phi 1 is equals to, it is minus 2 cot of 2 theta. Further, you can see that 2 and 2 will cancel out. This 2 will cancel out with this 2. So this will be cot of phi 1 is equals to, now since you have negative sign, you can take the negative inside, it becomes cot of minus 2 theta. Because we know cot of minus theta will be minus cot of theta. So using that basic formula, I'm writing this as minus cot 2 theta to be cot of minus 2 theta. So since we have cot on both the sides, we'll be getting the value of phi 1 to be equals to minus of 2 theta. So we got the first value phi 1. Now we need to find out phi 2. So for that we'll go for the second curve. The second curve is r square is equals to 16 sine of 2 theta. So let us take log on both the sides. We'll be getting log of r square is equals to, it is log of 16 sine of 2 theta. So using the properties of logarithm, log r square can be written as 2 log of r is equals to, on the right hand side you can write log of 16 plus, it is log of sine 2 theta. So just using the properties of logarithm, we can write in this way. Now we'll try to differentiate this with respect to theta. So differentiate with respect to theta. So we get 2 times of derivative of log of r will be 1 by r dr by d theta is equals to, log of 16 is a constant, its derivative will be 0, plus log differentiation will be 1 by, it is sine of 2 theta, into differentiation of sine of 2 theta will be 2 cos of 2 theta. This can further be written in the form of 2 into 1 by r dr by d theta is nothing but cot of phi. Since it is the second curve, I'll write as cot of phi 2. This will be equals to 2 times of, you have cos by sine, which will be nothing but cot. So we'll get cot of 2 theta. The value 2 will cancel out from both the sides. So this 2 and 2 will cancel out. So we're just left out with cot on both the sides. So therefore the equality gives us, the value of phi 2 to be equals to 2 times of theta. So we got phi 1 and phi 2. So therefore angle between the two curves will be, it is modulus of phi 1 minus of phi 2, which is nothing but modulus of phi 1 value is minus 2 theta minus of phi 2 value is 2 theta. So this will be nothing but modulus of minus 2 theta minus 2 theta will be minus of 4 theta. Since you have modulus, the negative sign will go off and you will just be getting 4 times of theta. So that's the angle between the two curves. But since this theta value is unknown, let us try to find out this value of theta. So to find out this value of theta, I'll go back to the question. So I'll be using these two given curves from the question. So from these two given curves, let me try to find out the value of theta. So let me take this as say equation number 1. So from the given curves, we have the first curve to be equals to r square sine of 2 theta is equals to 4 is the first curve. The second curve that we have is r square is equals to 16 sine 2 theta. I need to get theta from these two given curves. So I'll just try to take this r square on one side. So you have 4 and the sine 2 theta on the other side becomes divided by sine of 2 theta. So if you try to compare these two equations, so let me take this as say equation number 2 and let me take this as equation number 3. So if you try to compare this equation 2 and 3, the left hand side values are equal. So therefore we can just equate the right hand side values. So let us just try to compare equation 2 and equation number 3. So in that case, we'll be getting the value to be equals to. So you have 4 divided by sine of 2 theta, which is nothing but your equation number 2 right hand side value is equals to the right hand side of equation number 3. It is 16 times of sine 2 theta. However, you can cancel out the 16. So 4 1 times and 4 4 times. So that will be equals to, you have 4, just cross multiply the sine 2 theta on the other side. So you'll be getting sine 2 theta into sine 2 theta will be sine square of 2 theta. So here you'll just be left out with 1. Now just cross multiply, you'll be getting the value as 1 by 4 is equals to, it is sine square of 2 theta, or we have sine square of 2 theta is equals to 1 by 4. I've just rewritten the above step in this form, or sine of 2 theta will be equals to, so square goes on the other side, becomes square root. It becomes square root of 1 by 4. So square root of 4 will be 2. So we'll be getting 2 because it's square root of 4, which gives us 2. So sine of 2 theta, we have got the value to be equals to 1 by 2, or 2 theta will be equals to, so if you take sine on the other side, becomes sine inverse of half, and the value of sine inverse of half, will be 30 degree, which is nothing but pi by 6. Sine 30 will be half, therefore sine inverse of half will be equals to 30 degree, which is pi by 6. So we got 2 theta to be equals to pi by 6. So the value of theta will be equals to pi divided by, just cross multiply the 2 on the other side, becomes 6 times of 2 will be 12. So we got the value of theta to be equals to pi by 12. So if you go back to this equation number 1, so its value that you have got is 4 theta. So just plug in this value of theta back over here in equation number 1. So substitute theta back in equation number 1. So we have angle between the two curves to be equals to 4 times of theta. So theta value is nothing but pi by 12. If you try to cancel, you'll be getting 4 1 times and 4 3 times. So we get the solution to be equals to pi by 3. So hence the angle between the two curves is nothing but 60 degree or pi by 3. So that's the required solution. Let us move on to the next question. So the next question is, find the angle between the two curves. R is equals to a into 1 minus cos theta and R is equals to 2a cos of theta. Once again consider the first curve. R is equals to a into 1 minus cos of theta. So we'll take log on both the sides. So we'll be getting log of R to be equals to, it is log of a into 1 minus cos of theta. Using the properties of logarithm, I can write this as log of a plus log of 1 minus cos of theta. Let us try to differentiate with respect to theta. Differentiate with respect to theta. Derivative of log of r will be 1 by r dr by d theta is equals to log of a, its derivative will be 0, plus log differentiation will be 1 by 1 minus cos of theta into the inner differentiation 1 minus cos theta. So derivative of cos theta will be minus sin theta. So minus of minus will become plus. So we'll be getting plus sin theta. So 1 by r dr by d theta is nothing but cot of For the first curve, we're taking phi 1. That is equals to, we have sine of theta divided by 1 minus cos of theta. So let us use the half angle formula over here. Sine theta can be written as 2 sine theta by 2 into cos of theta by 2 whole divided by 1 minus cos theta. Its formula will be 2 sine square theta by 2. We can cancel out 2 and we can cancel out 1 sine theta by 2 in the numerator and denominator. We are left out with cos theta by 2 divided by sine theta by 2, which is nothing but cot of theta by 2. So on the left hand side we have cot of phi 1. So hence we get the value of phi 1 to be equals to theta by 2. So that's the first value we got, phi 1 to be theta by 2. So let us move on to the second curve. The second curve that we have is r is equals to 2a cos of theta. So let us take log on both the sides. We get log of r to be equals to, it is log of 2a cos of theta. Using the properties of logarithm, we get log of 2a plus log of cos theta. Let us try to differentiate with respect to theta. Differentiate with respect to theta. So log of r will be 1 by r dr by d theta is equals to log of 2a, its derivative will be 0, plus log differentiation will be 1 by cos of theta here. Derivative of cos theta will be minus of sine theta. We know 1 by r dr by d theta is nothing but cot of 5. It is the second curve, therefore I'll take phi 2 is equals to minus sine theta by cos theta will be minus of tan theta. So I need to express the right hand side in terms of cot. So therefore this can be written in the form of cot of, because it is minus tan theta. So cot is negative in the second quadrant. So we'll be getting cot of 90 plus theta. The cot of pi by 2 plus theta is nothing but minus tan theta. So therefore we'll be getting phi 2 to be equals to, it is pi by 2 plus theta. So we got phi 1 as well as phi 2. So let us write down the angle between the two curves. So angle between two curves is equals to this modulus of phi 1 minus of phi 2. That will be equals to modulus of phi 1 value is theta by 2. Phi 2 value is pi by 2 plus theta. Now this can be further written in the form of is modulus of theta by 2. If I take negative sign inside, it is minus of pi by 2. Minus of plus will be minus of theta. So this minus pi by 2, I'll write it as it is. Next we have theta by 2 minus of theta. That is half times of theta minus 1. So half minus 1 will be minus half. So minus half times of theta or theta by 2. So if you take a negative sign outside here, you will be getting pi by 2 plus theta by 2. But since you have a negative sign under modulus, it becomes positive. So you'll just be getting the positive value pi by 2 plus theta by 2. So that's the angle between the two curves. But since theta is unknown, we can find out the value of theta from the given two curves. So we'll go back to the two curves. So this is to find theta. So for that, let me take this as say equation number 1. So what are the given curves? Given the curves r is equals to a into 1 minus cos of theta. R is equals to 2a cos of theta. So Take this as equation number 2, this as equation number 3. If we try to observe the left hand side, they are equal. Therefore, we'll try to equate the right hand side value. So comparing equations 2 and 3, so we get the right hand side of equation 2 to be a into 1 minus cos of theta. The right hand side of equation 3 will be 2a cos of theta. Try to observe here, a will cancel out. So we have 1 minus cos theta over here. So I'll just retain 1 on the left hand side. On the right hand side, we have 2 cos of theta. So this minus cos theta on the left hand side, I'll send that on the right hand side becomes plus cos theta. So we have 2 plus 1 will be 3. So 3 times of cos theta. Or if I try to rewrite this one, so 3 cos theta will be equals to 1. Or cos theta will be equals to, if you cross multiply the 3, I'll be getting 1 by 3. Or theta will be equals to, so take cos on the other side becomes cos inverse of 1 by 3. So that's the value of theta. So theta will be cos inverse of 1 by 3. You can just plug in this value of theta back over here in equation number 1. Over here we'll try to plug in. So substitute the value of theta back in equation number 1. So we get angle between the two curves phi 1 minus of phi 2 will be equals. So what you have, pi by 2 plus theta by 2. So 1 by 2 I'll take outside, 1 by 2 times of theta. So here the value of theta is what? Cos inverse. We have cos inverse of 1 by 3. So that is the required solution we have. Let us move on to the next question. The question is, find the angle between the two curves. R is equals to a theta divided by 1 plus theta, and R is equals to a by 1 plus theta square. So let us take the first curve. R is equals to a theta divided by 1 plus theta. So let us take log on both the sides. We'll be getting log of R is equals to log of a theta divided by 1 plus theta. So it is in the form of log m by n. So we can write log m minus log n. So log of a theta minus log of 1 plus theta. Further, using the property log m into n as log m plus log n. So this can be written as log of a plus log of theta minus, it is log of 1 plus theta. Now let us try to differentiate this with respect to theta. So differentiate with respect to theta. Derivative of log of r will be 1 by r dr by d theta is equals log a is a constant, its derivative will be 0 plus derivative of log theta will be 1 by theta minus derivative of log of 1 plus theta will be 1 by 1 plus theta into inner differentiation 1 plus theta differentiation will be 1 itself. So the left hand side 1 by r dr by d theta will be nothing but cot of phi. Since it is the first curve, we'll take phi 1 is equals to, I can take the LCM over here. So the LCM in this case will be theta into 1 plus theta. Just cross multiplying this value, you will be getting 1 plus theta minus. So this theta, if you cross multiply, you'll be getting just as theta over here. Further, theta will cancel out, plus theta and minus theta will cancel out. You're left out with 1 by theta into 1 plus theta. So since on the right hand side we cannot express this in terms of cot, so therefore I'll try to express in some standard form, say in terms of tan. So if you take the reciprocal on the left hand side, the reciprocal of cot will be tan. So I'll be writing tan of phi 1. So since I have taken the reciprocal on the left hand side, I'll take the reciprocal on the right hand side. So its value will be theta into 1 plus theta, reciprocal of the right hand side value. So got tan of phi 1 to be equals to theta into 1 plus theta. So let us go for the second curve. The second curve is r is equals to a by 1 plus theta square. We take log on both the sides, we'll be getting log of r is equals to log of a by 1 plus theta square. So using the properties of logarithm, we'll be getting log of a minus log of 1 plus theta square. So differentiate with respect to theta. Differentiate with respect to theta. So derivative of log of r will be 1 by r dr by d theta is equals to differentiation of log of a, the constant will be 0 minus derivative of log will be 1 by, so we have 1 plus theta square into the inner differentiation. Derivative of the constant 1 will be 0. Differentiation of theta square will be 2 times of theta. So we have 1 by r dr by d theta will be cot of, since it is a second curve, we'll take phi 2 is equals to is minus of 2 theta divided by 1 plus theta square. Since the first, for the first curve I have expressed in terms of tan, so this also I'll try to express in terms of tan. So if you take the reciprocal on the left hand side, I'll be getting tan of phi 2. So take the reciprocal on the right hand side also, we'll be getting minus of 1 plus theta square divided by 2 theta. So we got the value of tan phi 1 and tan phi 2. As we observed in the previous problems, we have got the value of phi 1 and phi 2 independently. Since we got tan phi 1 and tan phi 2 in terms of theta over here, we'll try to first find out the value of theta and then how to find out the value of angle between the two curves. So for that, let me take this as say equation number 1 and this as equation number 2. We'll first find out the value of theta. From the given curves, r is equals to a theta divided by 1 plus theta and r is equals to a by 1 plus theta square. So let me take this as equation number 3, this as equation number 4. So since the left hand side are the same, just equate the right hand side value. So comparing equations 3 and 4. So equation 3 right hand side value will be a theta divided by 1 plus theta is equals to, it is a divided by 1 plus theta square. This a will cancel out. So let us just try to cross multiply. This theta times of 1 plus theta square is equals to 1 plus theta. If you multiply theta times of 1 will be theta plus theta into theta square will be theta cube is equals to, we have 1 plus theta. We can see that theta on both the sides will cancel out and we are left out only with theta q will be equals to 1. Therefore, the value of theta will be equals to 1. So we just try to plug in this value of theta back in equation number 1 and 2, that is tan phi 1 and tan phi 2. So just substitute theta in equation number 1 and equation number 2. So equation 1 is nothing but tan of phi 1. So its value that you have, just try to observe tan of phi 1 value. Tan of phi 1 is, theta value is 1 into 1 plus theta. So its value is nothing but 2. Go for equation number 2, that is tan of phi 2 will be equals. So try to observe this tan of phi 2 value, which is equation number 2. It is minus of 1 plus theta square divided by 2 theta. So minus of, it is 1 plus theta square will be 1 square will be 1 divided by 2 theta will be 2. So which is nothing but minus 2 divided by 2, which is minus of 1. So we have got tan of phi 2 to be equals to minus of 1. So since both the expressions are in terms of tan phi 1 and phi 2, I'll try to take the difference. Since we need to find out modulus of phi 1 minus of phi 2, phi 1 minus of phi 2. But we have not got the value of phi 1 and phi 2 independently, but they are in terms of tan. So therefore, I'll just try to consider this tan of phi 1 minus of phi 2. So it is in the form of tan A minus of B, which will be tan A, that is tan of phi 1, minus tan B, tan of phi 2, divided by, it is 1 plus tan A into tan B. It is tan of phi 1 into tan of phi 2. We know the value of tan phi 1 to be 2 minus tan phi 2 to be minus of 1 whole divided by 1 plus tan phi 1 value is 2, tan phi 2 value is minus of 1. So if you further simplify, minus of minus will become plus 1 divided by, it is 1, plus into minus will be minus of 2. So therefore you will be getting the value to be equals to 3 by minus of 1, which is nothing but minus 3 itself. So we have got tan phi 1 minus tan phi 2, tan of phi 1 minus tan of phi 2 to be equals to minus of 3. So therefore the value of phi 1 minus phi 2 to be equals to. So if we take tan on the other side, it becomes tan inverse of minus of 3. So if we take the absolute value over here, angle between the two curves will be modulus of phi 1 minus of phi 2. So since I am taking modulus, tan inverse of minus 3 will become tan inverse of 3. So that will be the required solution. So that's all I have for today. Thank you.